Most people who start to learn coding fail because they fall into hidden traps, myself included. Back in 2019, when I was still soul searching and really finding my path, I've given up more than twice, but I've learned how to avoid these pitfalls and I can help you do the same. In this video, I'm giving tips from real experiences to help you learn to code more effectively. But before we get into that, you need to understand these traps and how they block your progress in learning coding. Let's get one thing straight. You've been going about learning to code all wrong. Most people dive headfirst into learning a programming language, and that's not where your focus should be. Trap number one is learning programming languages before learning how to program. What do I mean by that, right? If you want to code effectively, you need to learn how to program first. Learn the fundamentals of computational thinking and problem solving. That's what makes a great software developer. If you don't grasp the fundamental concepts, it's going to be hard to write good code no matter what language or frameworks you're using. And in today's world, everyone's really just hacking things together with LLM, just copy pasting code from ChatGPT at a more rapid pace, which is a good thing altogether if you think about it for the tech industry. But what I'm seeing is there's going to be a huge shortage of actual builders with computational thinking skills, which is the foundation of what's required as a software developer. So let's break it down with an easy example here, right? Let's use spoken languages as the example. Back in primary school, you learn the basics of English: subject, verb, object. That's the logical sentence structure. But if we switch it over to Japanese, for example, that structure flips to subject, object, verb, right? So understanding these basic concepts in one language actually makes it easier to pick up another. It's the same with programming. You can't start coding in a new language without grasping the core logic first, right? One of our students, for example, he got hired as a PHP programmer. But here's the twist: we don't even teach PHP. So how did he pull it off? It's simple. He learned to code and he learned to program well. Computational thinking comes first, right? Once you understand the logic and how to problem solve using loops, conditionals, functions, and arrays and objects, right? Picking up the syntax of any language is just a matter of applying what you already know, and that's where most beginners trip up. Right? You're getting bogged down in memorizing syntax. I know I was, right? Instead of focusing on the underlying concepts that actually matter, right? And this brings me on to my second trap, which is memorizing instead of practicing. Memorizing is not a shortcut. It's actually the wrong path altogether. Coding is a lot like learning math. You can't just read a book and memorize formulas to get good at it. You have to practice. Watching tutorials is a great way to get the basics down, but if you really want to grow as a coder, just like how you really want to, for example, learn to swim, you don't learn to swim by reading a book, right? You learn to swim by actually swimming. Same for coding. You learn to code by building real-world projects to actually getting your hands dirty coding. And if you're not making mistakes and you're not coming up with solutions, that means you're not solving real-world problems. If you're just coding along and copy-pasting, you're not really building yourself. You're just doing it for the sake of doing it. So to gain coding skills, you can't just do that. All right. So the third trap is prioritizing motivation instead of discipline. Most people stop learning the moment the excitement fades. But ask yourself, is your goal to stay excited or is it to succeed? Obviously, it's success, right? So motivation is great, it gets you started, but it only lasts until you don't feel like doing it anymore. Discipline, on the other hand, is what keeps you going no matter what, all the way to your goal. Here's where people trip up most of the time, right? They start making excuses like, I'll do it tomorrow, I'm too tired today. And before you know it, tomorrow turns into next week and next week becomes next month, and eventually you just stop altogether. I know it because I've been there, right? I'll be honest, I'm a serial failure. I've given up 3 to 4 times, and the bad news is, right, I quit. But the good news here is I kept coming back. Honestly, relying on motivation, it just runs dry every time, right? But it was my discipline that pushed me through success. And this was the thing really to note here is learning isn't always a straight line. It's not about constantly moving forward, but about steadily moving upward, right? Even if that means running into challenges, unfortunately, many get stuck in this fourth trap, avoiding challenges instead of tackling them. Let's be real here. How many times have you told yourself, I'll do that when I'm good at it? It's a common mindset, but it's holding you back. Instead, try thinking, I'll give it a shot, and if I fail, I'll learn something new at the end of the day, right? So there's no losses here. Mistakes and challenges are inevitable in coding, so why avoid them? Challenges are a great opportunity to figure out your strengths and your weaknesses, to discover what works and what doesn't. That's where real learning happens. That's where you gain your skills. Instead of shying away from them, get used to diving to tracks of it, right? Get lost in it. I faced my fair share of challenges while teaching myself to code, and through all those struggles, I finally figured out what really works to get better at coding. If only I'd known these tricks back then, it would have made the journey so much more smoother, right? So first, to actually get better at coding, It's time to stop watching tutorials and start actually coding, right? Stop watching, just get your hands dirty, right? I've met countless people who complain about how hard coding is, how tough it is to learn. And you know what I found out? They don't actually code. They're just watching tutorials, copy pasting code. They're not really getting their hands dirty with code, right? They go through tens of tutorials a day, but they haven't written a single line of code. Tutorials are a great starting point, but if you really want to reach the finish line, you have to level up your game. You can't stay in level 1 forever, right? There's no tutorial to follow when you're in the real world. So start coding. Once you get a grasp of the fundamental concepts, don't just sit on it, apply it, build a project, right? And slowly try and perfect it, right? So in my company at Sigma School, that's exactly how we do it. Our lessons are 20% theory and 80% practical application. We focus on concrete outcomes. We don't just teach our students what an array is and leave it at that, right? We teach them what it is, and then we say, here's an app you have to create using arrays. For example, here's a project to do it, and that's how we approach every single lesson, every single day, all the way up to their final projects. And if you follow this approach, you won't just gain coding skills, you're gonna develop the ability to tackle anything that comes your way. Secondly, you need to start coding using a clear roadmap. So I've structured lessons into modules that guide you through every stage of your learning journey. We start with the fundamentals, which is computational thinking, and then we move on to things like front-end development with frameworks like React, and all the way to full-stack modules where we learn our backend, Postgres, GCP, and Node.js. That's where you connect the front-end and the backend, and you build a project of your own with a little bonus UI/UX module that helps you, mock up your design. Each module includes lessons designed to help you master that particular area. For example, in the front-end module, you'll build applications like a counter, like a login, like a dark mode application. That's what you need to do, right? Plan every step of the way to make sure you know exactly what you need, both in terms of hardware and software, right? The last thing you want is to get halfway through and realize you're missing something crucial. That's a surefire way to stall your progress and kill your motivation. So take the time to create a roadmap that suits yourself, do your research, figure out where you are now and where you want to be and how you're going to get there step by step, right? Now, looking back, I realized that many of the pitfalls I encountered could have been avoided or at least been reduced if I have a clearer sense of direction. I started with a side project and actively applied what I was doing instead of just following tutorials, right? Although I was a bit late to start, it happened just in time for me to get paid for multiple projects that ultimately paved the way for the coding school that I ran today. So thirdly, to actually get better at coding, get involved or build a side project, right? Contribute to open source. Having a side project is a game changer. It lets you apply what you've learned while also create and build something tangible that you can see come to life, right? 2 wins in 1. When I started my own project, I quickly learned that mapping things out is crucial. The first step is to ask yourself some key questions, right? What problems will my project solve? Who will benefit from it? Who will achieve these goals? And to make this easier, head over to Google and search for a value proposition map. Find a blank template and start filling out with the ideas that you have for your side project. And as you do this, remember that your project doesn't need to be perfect. Well, it needs to be useful, right? It needs to work. It cannot just break due to some bugs that you didn't fix, right? So it needs to be usable and useful, but it doesn't need to be beautiful. A project that cannot be criticized isn't the same as a good project. Just look at Facebook, X, maybe Twitter, right? And TikTok. They all serve a purpose. Even though they have their fair share of critics, once you've nailed down what you want to build, break your project into smaller parts. If you're building a website, for example, divide it into sections like header, main content area, sidebars, and footer. Then break each section down even further. Do you want a search box or drop-down menus in the header, navigation links in the footer? Figure out what you need in each part of your project. This is important because you won't find a tutorial that shows you exactly how to build the entire project from start to finish, right? The real-world projects I'm talking about, but you can find plenty of tutorials on how to create smaller components that combine into a bigger project. Next, start writing your code. Don't be afraid to make mistakes. This approach is 100 times better than just worrying about where to start or whether you're doing it perfectly. Forget all that, right? Making mistakes, solve problems, and learn from experience. If you're inexperienced, you learn along the way. And if your project or parts of it are similar to existing ones, open up the source code to see how they handle the features you want to implement, right? Learn from other people's successes and learn from their mistakes. Learning from it is a privilege. Take advantage of it. And when your code is finished, let other people review your code, right? And you review theirs. This is how peer-to-peer learning works. This is a real-world challenge that helps you develop your skills. For example, if you're comfortable with loops but haven't explored more advanced techniques like list comprehensions in Python, right? By reviewing someone else's code, you might come across a list comprehension that accomplishes in 1 line what would have taken you 5 lines with a loop. And having others review your code is constructive, especially when you're still learning. The second pair of eyes can catch the errors you've missed, suggest you improvements, or even confirm that your code is solid. You get better at coding and they'll know that too, as long as you don't stop learning. Whether you're job hopping to gain experience, joining a coding bootcamp, or diving into self-learning, take one of our students. For example, she graduated with an IT degree but realized her education lacked hands-on projects. So she made a smart move and she joined us, right, to fill that gap. She joined a coding bootcamp to fill that gap. And as a self-learner myself, I can tell you, it's not easy. It's not the easier path as people made it to be. Right? When I say don't stop learning, I mean take on something new. We're living in an era where technology evolves at lightning speed. It's so damn fast today. Whether it's AI, smartphones, cars, biotech, there's always something new on the horizon. It's not like the old days anymore. Things are moving so fast, right? Back in the days, new waves of development would take years or even a decade. These days, breakthroughs happen almost weekly. Every week there's a new tech stack. Every week there's a new framework. So don't get comfortable. Figure out what you're unfamiliar with, identify what's new, and get back on track. The key to staying relevant in tech is continuous learning and adaptation. Finally, beyond everything I've mentioned in this video, your personal learning style plays a huge role too. Some people absorb information best by listening to or watching, while others learn by doing and experiencing. The real secret though is to focus on understanding, to focus on building, not just memorizing and listening, right? This is the exact same approach that I would use if I could start all over again back in 2019. And this is the exact reason why my students can present us with incredible projects that they've built themselves. If you want to see what they've created, watch this video next. It's a proof that the right learning approach leads to amazing results. Thank you. See you in the next one.